Okay, we're at the point in Unit 1 where I feel maybe it's a good time to take a pause and think about the two different types of sequences we have, how you could tell the difference between the two, and maybe even look at a third one called other for now. We'll have a specific name for it when we get to the next section, but for now we'll call it other. And the blue sequence on the left, I think it's an arithmetic because I put it under the word arithmetic, and I'm going to show you how I know. Well, if you think something is arithmetic, the first thing you should do is to check for a common difference, which is D, okay? To have a common difference, what you need to do is you need to check term 2 minus term 1 and see what you get. Then see if the third term minus the second term is the same. Continue that pattern. See if the fourth term minus the third term is the same as well. If those differences are in common, it's called a common difference, and it is indeed an arithmetic sequence. All right? You're checking to see if it has a common number that you add every time or subtract to get from term to term. So you go over to your calculating device and you take 14, which is the second term, minus 8, and you get 6. Then you take 20 minus 14 and you get 6. Then if you still need your calculator for it, you do 26 minus 20, which is 6. And since it has that number in common, it's a common difference, and we are arithmetic. So the difference here would be 6. If they wanted you to write a formula, you would say the first term is 8. To get to any other term, you take the previous term plus 6. That's arithmetic from start to finish. Notice I used U1 because I see a list of numbers, this being the first one, U1. Next, let's go to the middle one, geometric, and for that, we're not looking for a common difference, we're looking for a common ratio. And this time, instead of it being U2 minus U1, you're going to check to see what U2 divided by U1 is. Then you're going to check to see if U3 divided by U2 is the same. Then you check to see if U4 divided by U3 is the same as well. And if they are, you probably have a geometric sequence with that number as your common ratio. All right? Now for this one, I'm not going to go to the calculator to save time because I think we can handle this in our head, right? What's 16 divided by 8? 2. 32 divided by 16? 2. And 64 divided by 32 is 2. Therefore, the common ratio is 2, and it's a geometric sequence with U1 equal to 8 and any other term equal to a term before it times 2. Sometimes you'll see in the book or on my worksheets that they'll write it this way, which is the same thing. They just put the multiplier 2 in front of un minus 1. Okay? So that's either or. Just like this one could have been 6 plus un minus 1 if you wanted it to be. All right? Doesn't matter which order that you do them in. So those are the basics of geometric, which is in red, and arithmetic, which is in blue. Now, other. Well, let's go ahead and apply what we just tried. Let's go through this little flow chart here in our head. Say, okay, first of all, is it arithmetic? If so, what's 7 minus 2? 5. What's 22 minus 7? 15. So right away, is it arithmetic? No. This green one is not arithmetic because I didn't get the same number both times. So it's out. All right? Now let's check to see if it's geometric. So you go through this process. Is it arithmetic? No. Is it geometric? What's 7 divided by 2? 3.5? Good. What is 22 divided by 7? 3 point something, but not 3.5. What is it? 3.1-ish? Okay, so if this is 3.5 and this is 3.1, not geometric. So it's neither of those things. So we need this step 3. What do we do next if it's neither of those things or neither of those things? So we're at the point where it's neither arithmetic nor geometric, so we have to find out what this other might be. And to find the other, we have this thing that I call the CROD. So what is this CROD? Well, it stands for the common ratio of the differences. So here's what I want you to do. Go back to when we said, what does this change by? Or what is 7 minus 2? It changes by 5, right? What is 22 minus 7? Or what does it change by? 15. Then check to see what 22 and 67 differ by. 45. And as you sit there looking at those numbers, you might think, those numbers have a pattern to them, right? They sure do. So we've already checked for the differences. They're listed right there, right here. These are called the differences. Now we want to see if they have their own common ratio. Do they? 5 times what is 15? 3. 15 times what is 45? 3. So tripling or multiplying by 3 has something to do with this pattern, which we already know it does. It's times 3 plus 1. But let's see how the rest works. You ready? So at this point, you're just going to tell me what the first term was. You're going to act for a minute like it's geometric and it's just times 3. All right? I know that's wrong, but go ahead and start there. So say u1 equals 2. To get to the next term, I know that it involves multiplying by 3. If I stopped there, the answer would be wrong, right? Because 2 times 3 is 6. 7 times 3 is 21. 22 times 3 is 67. The last step is to just tack on a little adjustment number. What are we off by? 6, 21, 66. We're off by 1. That's how you find the missing link right there. So that would be the pattern in this example called other. And there's a name for it. It's kind of geometric, but it's been shifted. So it's known as a shifted geometric sequence. And we'll learn more about those in section 1.3.